Hello everyone, welcome to another video in my channel. In this video, I'll be solving number 2 theory question of the NECO 2024 Further Mathematics. In the previous video, I did the solution to the number 1 question. Now we have if alpha and beta are roots of 2x squared minus 3x is equal to minus 1, find the value of alpha squared plus beta squared and alpha cube plus beta cube, then alpha over beta plus beta over alpha. What am I going to do to solve this problem? Before I proceed, I would like you to do me a favor. Please like this video, subscribe to my channel if I haven't done so, and please turn on the notification bell so that when I upload videos like this, you will be the first to be notified. I would also like you to share this video to your loved ones and also leave comments in the comment section. Now to proceed, we are given a quadratic equation which is 2x squared minus 3x is equal to minus 1. So let us do well to rewrite it as 2x squared minus 3x plus 1 is equal to 0 by adding 1 to both sides of the equation. Now this is exactly in this form: ax squared plus bx plus c is equal to 0, where a is equal to 2, b is equal to minus 3, and then c is equal to 1. So we need to find the values of these combinations of the roots of the equation. The first one is alpha squared plus beta squared. But before we do that, let us find the expression for alpha plus beta and then alpha beta. In the previous videos in this channel, I derived the expression for alpha plus beta to be minus b over a and alpha beta to be c over a. I will post the link to that video in the description. So, being that b is minus 3, minus b over a will now become minus 3, and then a is 2. So I have 3 over 2 as the sum of roots. The product of roots will now become c over a, which is 1 over 2. So we have the product of root as 1 over 2 and the sum of roots as 3 over 2. Good. Now, to solve the first part, we are given alpha squared plus beta squared. We need to generate an expression where we have alpha squared plus beta squared. So, what are we going to do? We are going to use alpha plus beta all squared and then expand it using binomial expansion. When we expand it, we have alpha squared plus beta squared plus 2 alpha beta. So this is the expression we are required to evaluate. So I will now take this one to the other side. So alpha squared plus beta squared will now be equal to alpha plus beta all squared minus 2 alpha beta, simply by subtracting 2 alpha beta from both sides. Now we now see that we have expression for the sum of roots and then the product of roots. So let's put in the values of the sum of roots and product of roots here and here. It becomes 3 over 2 all squared minus alpha beta is now 1 over 2. So simplifying, 3 squared is 9, 2 squared is 4, minus 2 times 1 over 2 will give us 1. So the LCM of these two fractions will give us 4. 4 divided by 4 is 1. 1 times 9 is 9. Then 4 divided by 1 is 4 times 1 will give us 4. So alpha squared plus beta squared is equal to 9 minus 4 is 5 over 4. Next, we are required to find the value of alpha cube plus beta cube. Again, we do not have an expression for it, and so we are going to derive the expression where these two terms will be contained in the expression, and I'm going to do that using alpha plus beta all cube. Using binomial expansion again, I have alpha cube plus 3 alpha squared beta plus 3 alpha beta all squared, then plus beta cube. So we now have alpha cube plus beta cube, which is what we are looking for, then plus I will factorize 3 alpha beta from these two. 3 alpha beta remaining alpha plus beta, and then equate it to alpha plus beta all cube. Now let us take this part of the expression in the right hand side to the left hand side. So we have alpha cube plus beta cube equals to alpha plus beta all cube minus 3 alpha beta times alpha plus beta. So we have this. I can still factorize alpha plus beta here. I have alpha plus beta, then alpha plus beta all squared minus 3 alpha beta. Again, we see that there is an expression for alpha plus beta, which is sum of roots and the product of roots. So let us put in the values of the sum of roots and product of roots in this expression. So alpha cube plus beta cube will now give us alpha plus beta is 3 over 2. Then another 3 over 2. This time we'll square it, minus 3 times 1 over 2. Good. And then we finish up. Now 3 over 2 times 3 squared is 9. 2 squared is 4. Minus 3 over 2 here. Let's open the bracket. We are given 3 times 9 is 27. 2 times 4 is 8. 3 times 3 is 9. 2 times 2 is 4. The LCM is 8. 8 divided by 8 is 1. 1 times 27 is 27. And 8 divided by 4 is 2 times 9 is 18. So alpha cube plus beta cube will now be 27 minus 18 will give us 9 all over 8. So we have 9 over 8 as the value of alpha cube plus beta cube. Now, lastly, we are also required to evaluate alpha over beta plus beta over alpha. We can rewrite it as alpha beta, which is the LCM. Then this is alpha plus beta, squared here and squared here. Good. So we have an expression for this. Now this expression, which is alpha squared plus beta squared, we got it to be 5 over 4, then divided by the product of the roots, which is 1 over 2. Simplifying, 5 over 4 times 2 over 1 will give us 5 over 2, because this and this will cancel out to give us 2 here.